This is the summary for Lesson 10, Introducing Graphs of Proportional Relationships. And so the first part of the summary describes a situation where you're buying blueberries, and those blueberries cost $6 per pound. So that $6 per pound is the constant of proportionality. It is the unit rate. It shows you, or it tells you, that the cost in dollars of the blueberries is proportional to how much the weight of blueberries that you buy. So what are the pounds of blueberries that you purchase? So if you purchase 1 pound, it's going to cost you $6. 2 pounds are going to cost you $12. 3 pounds are going to cost you $18. So every time it's $6 per pound, but then it's times the number of pounds you purchase. So it's 1 pound, 2 pounds, 3 pounds, 4.5 pounds. So you can purchase, it doesn't have to be a whole number of pounds, because you can buy a half a pound of blueberries. So y over x is the constant of proportionality. That's equal to 6. So you can fit it into this equation, y equals kx, where this tells you that y is 6 times the value of x. So y is equal to 6 times the value of x. So y equals 6x. So the constant of proportionality, that's the unit rate, that's the cost. That's $6 per 1 pound, or $6 per pound. Now, if the graph were something other than blueberries, say sandwiches, for example, well, they're not going to sell you a half a sandwich, more than likely. So in that case, you would not connect the points. You would just graph the points, and it would just be a whole number of sandwiches, and you would not connect them with a line if you're going to graph that situation. So it's often not possible to buy 4.5 sandwiches. So even if only points make sense in the situation, sometimes we connect them with a line anyway to make the relationship easier to see. All right, so two things you should look for: a straight line, and that line goes through the origin. If you have something other than that, then it's not going to represent a proportional relationship. So for example, if the graph is a curve, that's not going to represent a proportional relationship. If you double 2 to 4, y is not going to double. Y is not going to go from 3 to 6. Y is going to go to something other than 6. It's not a proportional relationship. So when you double it, double x, y does not double. Something else happens. On the other hand, if you have a straight line, but it does not go through the origin, that's not going to represent a proportional relationship either. And in the same situation here, same idea, if I double x from 2 to 4, y goes from 3 to 4 as well. Not 3 to 6. It should go 3 to 6 if it were a proportional relationship. But when it doubles, it goes from 3 to 4. When x doubles from 2 to 4, y goes from 3 to 4. So it does not double. So another piece of information that tells you it is not a proportional relationship.